Okay, this video will be about data analysis and conclusions. So data analysis and your conclusion are the last two parts on your lab report form. So of your lab report form, the last two, it's the back page. And all this information that's on here, there are guided questions for each section. So for data analysis, there are a bunch of questions. Make sure you answer all of them. Make sure you have a nice, good analysis section. The same with conclusion. There are several questions. If you answer them all, you should be in good shape. I want to make sure you understand what they mean though. So for data analysis, you want to write your data out in words. So if you notice that plant A grew a total of 4 centimeters and plant B grew a total of 10 centimeters, write that out as sentences. Plant A grew a total of 4 centimeters. Plant B grew a total of 10 centimeters. So you want to write out your data that you have in your table, or write it out in words. So write out what your data was. Remember from data tables and graphs that we want to communicate our results in as many ways as possible so people understand it. So data tables communicate our results in numbers, graphs communicate our results in pictures, and our data analysis communicates our results in words. So that way, regardless if you're a number person or a picture person or a words person, you can understand what the results of the investigation were. Next, you want to identify patterns. So what things did you notice? Was plant A smaller the entire time and then grew towards the very end? Was plant B kind of like middle height the entire time? Things like that. What patterns do you see? What things did you notice about your investigation? Next, did you test your question? It's easy to ask the scientific question, create a procedure, and do the investigation, but not actually ever answer the correct question, the question you're asking at the beginning. So for example, if I do an investigation where I'm comparing how much water I give to plants and if that affects their growth, if I give each plant the same amount of water, then I'm not testing my question because I didn't change how much water each one got. Or if my question is, what is the effect of bleach on pond water, the one we discussed before? Does it kill the bacteria in the pond water or not? If you don't ever give the water bleach, then you're not testing your question. So you want to make sure that the procedure you did and the steps you did actually are testing the question you asked to begin with. And it's pretty common for that to not happen. If you tested your actual question, then your results are valid. That's a key word, valid. So if they're valid, that means that you actually tested the question you were setting out to answer. If you didn't, then your results are invalid. They're not valid. So that means that you actually tested the question you were asking in the first place. And then next, what are your variables? What was your independent? What was your dependent? What are some constants? How are they related? So list out in sentence form, what are your variables? Okay. While you're doing your investigation, you might also want to do some math and do some statistics on your information. And we're going to go through and actually do these examples. So the mean, that's where you add up all the numbers and then you divide by the total number. And going through and doing these on your results can help you identify patterns like we showed in the first slide. So these are my numbers, 1, 7, 3, 5, 2, and 3. I'm going to add up all the numbers to find my mean. So 1, marker doesn't work. I'm going to do this in blue because my green ran out. 1 plus 7 plus 3 plus 5 plus 2 plus 3. So 1 plus 7 is 8. 8 plus 3 is 11. 11 plus 5 is 16. 16 plus 2 is 18. And 18 plus 3 is 21. So that's step 1. You add them all up. And then you divide by the total number. So there are 1, 2, 3, 4, 5, 6 total numbers. So we divide this by 6. So 21 divided by 6. 6 goes into 21 3 times. 3 times 6 is 18. 21 minus 18 is 3. Add a decimal, bring down to 0. 6 into 30 is 5. So my mean, or sometimes it's also called average, is 3.5 of this information here. Okay? Median is when you line up all the numbers in numerical order and you pick the one in the middle. So 1, 2, 3, 5, and 7. So 1, 2, 3, 3, 5, and 7. So I put them in order from smallest to largest. And then you pick the one in the middle. My middle is right here, in between the two 3s. Since they're both 3, my median is going to be 3. So my median of this set of data is 3, because it's what comes in the middle of the line. Mode is the most common number. It's the number that's mentioned the most. So we have 1, 1, 1, 7, 2 3s, 1, 5, and 1, 2. So my mode is also going to be 3, because there are 2 3s in my data. And so these 3 can really kind of show you patterns and help you identify what happened with your data. Mean comes in handy quite often. If you do several trials, you're not going to want to list every single trial. You'll want to find the mean or average of the total and go off of that. Okay? And the last one is range. And we're going to use range almost every single investigation. So you take the biggest number minus the smallest. So my biggest number is 7, and my smallest number is 1. So 7 minus 1 is 6. So my range for this set of data is going to be 6. And what this does, it tells you if your data is reliable. Okay? Basically, does your data make sense? And this is a judgment call, so it's kind of up to you. So what you do is you look at your range. If it's a very small number, that means your data is very reliable. What that means is that the individual numbers are all pretty close together. You don't have one giant number or one very tiny number, but if you have a small range, then your data is very close, kind of in the same neighborhood, okay? They're very close. So it's reliable, so more than likely your data makes sense. If you have a very large range, say we had a range of 27 or something like that, that would mean that we have a very large spread between our smallest and our largest numbers. And that tells us that our data may not be reliable. And what that means is that there's some number that's very large or very small that can be very different from the rest of your numbers. And you want all of your data to kind of be in the same neighborhood, be very close. So if your data is not reliable, then you might want to go back and say, well, was there one trial or one part of my investigation that got messed up, or was there something that affected it that I didn't think about? Things like that. So reliability is basically, is your data close in numbers, or is it kind of all spread over the place? And we want close, because that makes it more reliable. Okay. So the last section of our lab report is our conclusion. And there are several main questions that you want to ask yourself and answer on your lab report form. First is, was the hypothesis supported? Note this word. I do not ask, was your hypothesis correct? The correct term is supported. We ask that because in science we have to do experiments over and over and over and over and over and over and over to make sure that that information is actually correct. More than likely in our class we will only do an investigation once. So we haven't tried it enough times to say that it's correct or true. So you can only do that over, tons of trials. So we're going to use the word supported. Basically it just means, does your data tend to suggest that your hypothesis is right? So we're going to use supported. Yes, my hypothesis was supported because the data matches what my hypothesis was. Or no, my hypothesis was not supported because the data is the exact opposite of what I thought my hypothesis would be. So we're going to use the word supported instead of correct. What does your data mean? So write it all out in words and then tell me, well, what does that mean? So what? Plant B, grew twice as tall as the other ones. What does that mean? Explain it to me. Explain patterns. So data analysis, we're just writing out the patterns, we're writing out the information, but there's no explanation in the data analysis. The explanation comes in the conclusion. So explain what the patterns mean. What does it mean if this one grew a lot faster than the other one? If one plant was smaller the entire time, what does that mean? Explain it. Improvements. Were there parts of your investigation that could be fixed or improved or made better? Could you have tried more plants? Could you have done it for a longer period of time? Could you have watered your plants less and not, killed them? Things like that. What about your experiment could be improved? And then also, this is one kids miss a lot. What other investigations could be done? So what's something similar that could be done to your experiment that could give us similar information? So for my tomato plant example, what is the effect of fertilizer on tomato plant growth? I could then do a related experiment. Well, which brand of fertilizer has the best results? Or what is the effect of fertilizer on sunflower growth? So these are other investigations that are similar to the one you did, but not quite the same. And then lastly is the CER method. The CER is a really good way of writing your conclusions, and it's also a really good way of writing out answers to essay questions on exams. So we're going to use this not just for investigations, but for tests as well. And I definitely encourage you to use this for other classes. This will give you really good answers for essay questions. So first of all, claim. What's your answer? So they ask you a question or your scientific question for your investigation. Claim is really basic. What are you answering? What's your answer? For the fertilizer growth on tomato plants, my claim could be the more fertilizer you put on a plant, the taller it will grow. That's my answer. Pretty simple. Let's put it out there. Evidence is the E in the CER. Evidence. What's your proof? So how do you know? So for my fertilizer example, I might say, plant D had the most amount of fertilizer and also grew the tallest. That would be my evidence of my answer, which was that more fertilizer is better. And then lastly is reasoning. So reasoning is the R of CER. And this is where you explain. I might say something like, my original question was to find how much plants grew if they had fertilizer versus no fertilizer. The plant that had the most fertilizer grew the most. Therefore, I know that adding more fertilizer helps plants grow better. Okay? Sometimes the reasoning can seem kind of dumb. Like, I've already explained this, why do I need to say it again? But reasoning, it's kind of like the procedure in our investigation. Assume that whoever's reading your answer has no clue what you're talking about, and explain it down to the finest detail exactly what you mean, so they know exactly what your answer is. So CER method, investigations and tests. What's your answer? What's your proof? And then explain it.